Hello everyone, I welcome you all to today's session wherein we will be covering the second part of the ERPV, which stands for equation, ratio, proportion and variation. So in today's class we shall be looking at the concept of what do we mean by consistent set of equations, inconsistent set of equations, consistent with infinite solutions, consistent with unique solution, right? We shall be looking at all of that. So these video series, if you look at the previous video, right, in the same series ERPV, we have discussed couple of points. One was how do we frame the equation, second was how do we solve it, and I told you in the previous class that framing the equation will be more important than solving the equation. You need to focus more on learning how do we frame it, right. Today's video, as I said, is a specific topic, but again we will try to cover today's video quickly because we have around 15 minutes time for doing this, right. So we'll have to do it quickly, of course, along with taking up some examples. For more detailed learning, please ensure that if you're interested in doing your MBA, cracking CAT, please reach out to the nearest center, right, and enroll in a course of your choice, right, in the batch of your choice, right, wherein we'll be discussing these concepts at even greater depths, right. We at time are national leaders with respect to the number of call getters, with respect to number of converts, with respect to the audited results, right. So that way we will be able to help you in achieving your goal of doing an MBA from a really good college, right, very efficiently, right. Let's get started with the video. So in today's video we shall be looking at, as I was saying, the concept of consistent, inconsistent and consistent with infinite solutions. Now if you take set of equations a1x plus b1y equals c1 and a2x plus b2y equals c2. If you take the set of equations, if you were to plot them on the graph, these two set of equations will represent two lines. So the two lines that we have could either be like this, entirely parallel, could either be like this, intersecting, or could also be like this, that is entirely overlapping, one on top of each other. So these are the only three possibilities that we have for a pair of lines, right. Now one more thing, in graphical approach, whenever or wherever the lines intersect, that is called as a solution point, right. That's called as a point of solution whenever the lines intersect. So that means in this case, when the lines are intersecting only once, we shall have only one solution. In this case, when the lines are infinitely intersecting, they are intersecting at every point, we'll have infinite solutions. And here, since parallel lines, they will never intersect, they will have zero solutions, right. Now these three cases corresponds to three different cases here also. So the case 1, which corresponds to the line drawn in third quadrant, is the case or the condition when the ratio of x coefficients is same as ratio of y coefficients is same as ratio of the constant terms. So whenever this happens, a1 by a2 equal to b1 by b2 equal to c1 by c2, then such set of equations will be called as consistent equations with infinite solutions. Now why infinite? Because in this case the lines will be overlapping, one on top of each other, there will be infinitely many solutions. Second case, if I pick the second case, case 2, or rather what I'll do is I'll take the parallel line case first. So this corresponds to the case in the first quadrant, case 2, the case of parallel lines. So the condition for parallel lines case is the ratio of x coefficients is same as y coefficients, but is not same as constant terms ratio. So this is called as inconsistent set of equations, and they will be having no solutions, zero solutions. And the third case that we shall have, case 3, Now this corresponds to the intersecting lines case, which is in the fourth quadrant. So that will happen when the ratio of x coefficients is not equal to ratio of y coefficients. A1 by A2 is not equal to B1 by B2. In this case, we say the system of equations are consistent with unique solution. Unique means single, because as you can see in the graph as well, in this case there is only one point of intersection, thus one solution. So these are the three cases that we come across. You may note them down, right? And also recall or remember the corresponding graphical case. For example, for this it's the overlapping lines, for this it is the parallel lines, for this it is the intersecting lines. So today's video is entirely based on this logic, this concept, right? Now we will take up few examples also following this, right? Please note this down. Now we will move on to some questions. So let us look at the very first example that we have here. So the question says, if the following system of equations have exactly one solution, so they have only one solution means what? Intersecting lines, right? Then what can we say about the value or values of k? So this from our previous discussion would mean this is pair of lines which are intersecting. So if they are intersecting, what was the condition? Consistent equation with unique solution. So that is A1 by A2 not equal to B1 by B2, right? This was the condition. C1 by C2 we don't even care, right? We are not even concerned about C1, C2. So when you solve this, 3 goes 7 times, 3 goes 3 times. So the value of k should not be equal to 13 into 3, 39 by 7. So as long as k is not 39 by 7, not equal to 39 by 7, the system of equations will have a unique solution. But the moment k is 39 by 7, then the system of equations will have no solution. Then they will convert into parallel lines. You can see that. So if you take k as some other value, let's say 5. So if you put k as 5, so the ratio is 13 by 5, 21 by 9, they are not equal. So they will be intersecting lines. But the moment k takes 39 by 7, what happens? 13 by 39 by 7, and this is 21 by 9. 13 will go 3 times, so left hand side becomes 7 by 3, right hand side also after simplification becomes 7 by 3. They will become equal. So they will not be having unique solution, right? They should have exactly one solution. So thus any value of k not equal to 39 by 7 will satisfy the given condition that the system of equations have unique solution. Okay. One more question on same line, similar lines. Look at this. If the following system of equations have at least one solution, so that means it's not the case of zero solution. Now when I say at least one, it could be one or more. Now when I say more, it could be infinite also, right? One or infinite. Then what can we say about the values of k? Let's look at it. So if you look at the ratio, firstly A1 by A2, B1 by B2, C1 by C2. So one thing that we can clearly notice here is B1 by B2 is not equal to C1 by C2. If they are not equal, can I say this system of equations can never be overlapping lines, because the condition for overlapping lines was A1 by A2 equal to B1 by B2 equal to C1 by C2. But right now we clearly see these two are not equal. Thus can I say, when I say at least one, it can never be more solutions. That is, infinite solutions is not possible. So that means this should also be indirectly a case of exactly one solution. I hope the logic is clear. So for this to be exactly one solution, A1 by A2 should not be equal to B1 by B2, which is, when you solve it, k should not be equal to 3 into 4, which is 12. So that means for any value other than 12, this system of equations will have one solution. But if you take k as 12, then what will happen? Then this system of equation will have no solution. We don't want that. So what can we say about the possible values of k? I'll say there are infinitely many values. Any value other than 12 will work. Alright. I hope we are clear with this question also. Now one more. it says if the following system of equations have no solution at all. So when I say no solution, zero solution. And what's the condition for zero? There's a very straightforward condition for that. It's A1 by A2 equal to B1 by B2 should not be C1 by C2, which is clearly true. A1 by A2 is 1 by 3, C1 by C2 is 3. They are not equal, of course. Now, for them to have zero solutions, this equality should happen. And when you equalize them, 1 by 3, so K will become 12 into 3, which is 36. So if you put K as 36, the system of equations will have zero solutions. But if you don't put K as 36, then the given system of equations will have, right, unique solution. So for K equal to 36, there is no solution. For any other value besides 36, there will be one single solution. Okay. So in your competitive exam, I am just reading this. In your competitive exam, you come across questions which are asked on these lines, right, wherein the examiner would be talking about consistent equations, or he would be talking about the case where the system of equations have no solution or single solution, unique solution. You should be aware of the corresponding conditions for that. Just to recap, the condition for infinite solution is A1 by A2 equal to B1 by B2 equal to C1 by C2. Condition for no solution is A1 by A2, B1 by B2 not equal to C1 by C2. Condition for unique solution is A1 by A2 not equal to B1 by B2. So if you know these conditions, then any candidate will be able to tackle such questions no matter how complicated the language of the question is. So I hope we have followed it, alright. So with this, we have come to the end of the video today, right. So for more videos like this, right, because we keep on releasing the videos on daily basis, alright, on every week, weekly basis, daily basis, alright. So for getting more videos, access to more videos, please ensure that you subscribe to the channel, right, and please hit the bell icon, right, because that will be giving you the notification regarding the new videos as and when they release, right. On that note, let me end the session here. Thank you and all the very best.